You may have seen this before at Supercon 2023. This was my brother and son and I working on a hack with the support of a lot of other people, frankly. And we just put this Etch-a-Sketch frame on here with the two analog pots. Had a lot of fun with it. But I've got another Etch-a-Sketch project, this time in the form of an SAO. There we are, ready to boot up. There it is. So this was a lot of fun to put together. This has a 128 by 128 OLED screen, two analog pots, and an accelerometer hiding on the back side. There's the accelerometer. And two options for SAO sockets. One can go right in the bottom, like this one, or it can extend out this edge. Some solder jumpers up here to choose the power for the connection to the OLED. And the pots go on there. These little caps that go over the pots. Snap on there, and you're off and running. So I think there's a lot of possibilities here with the fact that there's the two knobs. You could do Pong or some other game. And then when you add the accelerometer in there, you can do all sorts of other fun stuff. Oh, the most important feature for it to make an Etch-a-Sketch-like is accelerometers. This is what the board looks like when you get it. The surface mount stuff is down on the back side. There's not a lot there, but a little bit. And one of the really fun features that I developed for this is a way to align and secure the screen to the back of this board without anything being visible on the front. So these two little holes here get covered up with the pots, which you can see. But before you do that, you solder in these two 2.5 millimeter copper spheres. They can be soldered in from the back side, I guess the bottom side, or if you put this on a silicone mat, you can solder from the front side. And then these nestle in the holes there, and then when this screen gets placed on here, those balls line up with these holes, and then if you squeeze those together, that provides alignment, left, right, up, down, and basically that whole plane. And then all you have to do is solder these four little bits of pin that stick out against the surface mount pads, and that secures and aligns the screen just like is shown here. So here it is when it's assembled. You can see the little copper ball in there, and then the screen is sandwiched in there. I think it does a good job of protecting the screen too. Since this is effectively all I2C controllable, so the OLED and the accelerometer are both on the I2C bus. The pots are connected to the analog input of the accelerometer chip on there, but I didn't realize it. The range of input is 0.9 to 1.8 volts, and I need 0 to 3.3 to get the full range of the pots that I put in here. The pots also are connected to GPIO 1 and 2 of the SAO port, and that's what I'm using in that demo. So what's actually driving this is just an RP2040, and through this SAO connector here, and all that's going on is I'm getting power from the badge or the host through this port. Power goes to the RP2040, and then that's where the code is running that spits out the I2C and connects to the ADC pins, connects the ADC pins of the RP2040 to these GPIO pins, and that's how this all works. This is kind of a necessity is the mother of invention sort of thing. That is also another project I worked on and am sharing with people, and it's exactly what it says it is, an SAO demo controller. So these more advanced SAOs have I2C, and I wanted to be able to offer a way to put those together and demo them kind of standalone before people got their hands on them to be able to work with them.